Hello? Alright. No, it's enough, No, I don't want to hear my... Oh my god. Okay, good. Alright, 2 viewers already. Alright, I have to go through all of this. I've been streaming for a minute. Okay, that's enough. Alright, I assume people can hear me. I can see it in the corner, people can hear me. Alright, so, this is my first stream back in a while, so let's get some context. If I can find it. Alright, come to the front, let's stream. Alright, let's get context. So let's find out when's the last time I streamed. Channel. Alright, now mute tab. Alright. Okay, so I assume it's muted. Yeah, it's definitely muted. So, here. Okay, this doesn't help. Where's the... How do I find videos? Alright, there we are. Okay, so... this was 6 days ago. FPLC, starting type checker on IR. So, this is when I just got the, I got the IR in. So this is the LIR, the lowered IR. So I got the parser to generate the LIR, and then I run the type checker on that. And that was 6 days ago? Yeah, let me find out, this schedule. Yeah, I wish I could find out when my streams were. Anyway, let's go to my YouTube. Let's go to my YouTube. Alright, let's... okay. Here's my YouTube. It's all locked down because it's just another account. Manage videos. Alright, and then you see these two here. This is stream... let's find out what stream that is. It's stream 12. This is stream 12, and this is stream 11. Those are the two ones here. And those were like a while ago, right? They were like, you know what? Let me just click on this thing. When was this? 7 days ago. Okay, so this was 31. So let's say, let's assume that I've been out of the game for basically a week. And the question is, what have I been doing during that time? Because I haven't been streaming and I haven't been posting. Well, the issue is, and there's a reason why the stream is named Researching IRs and the Sunk Cost Fallacy, is because basically I got myself stuck in a loop where I wanted nothing to do with trees. So my original compiler, the first one where I actually made, well, not the first iteration where I made the most progress in, was basically a two-step process. First, you run over the syntax, generate a tree, HIR. So it's just a tree AST, essentially. Run over the syntax, generate a tree. After that, you run type check over the tree. That's the next thing you do in that step. You type check over the tree. And next, run over the tree, generate LIR. That's it, simple. So you generate a tree. So you're just running over, that's an AST, that's a normal compiler. That's what a normal compiler would do. Run over and generate an AST. Next, you traverse the AST recursively, you type check it. And after that, you run over the tree and you generate, I don't know, whatever you want. Your another intermediate representation, or generate code. And this is basically how I wanted my compiler to go. So generate syntax, type check, and all of these things. But eventually I hit a stop, right? I hit a stop. I wanted this ambitious thing, and what was it? Was essentially control flow types, right? So essentially, take a look at this code right here. So this is a loop do. Anyway, it's just a loop that loops over stuff. And let's say you have let c equals false if c brk something, right? You're breaking out of the loop entirely. So so how loops get typed, right? I'm pretty sure let's just hope that you're familiar with the loop expression, loop expr. It's like C's loop brace, essentially the same thing. Rust's loop brace is equivalent to loop just empty tuple in my language. So a loop that has no break instructions is essentially a infinite loop, right? And anything after is unreachable code. And how is that typed? Well, it has a functional abstraction. It's typed as the bang or the no return in Zig. Essentially, it's called the bottom type. This is called the unit type, the unit tuple, because there's only one representation of it. There's only one construction, right? That's the unit type. You can only produce one value. Like there's no different kinds of values. There's only the unit, and that's called the unit type. And there's also a thing called the bottom type. The bottom type is the parent of all types. Essentially, what the bottom type is that you cannot produce a value of this type. So with the unit type, there's only one value you can produce. With the bottom type, there is no values you can produce. That means you can only really produce the value if you kill the program, essentially. So let's say let v equals loop forever. This is well typed because anything after is no return. And you can't read v because the program would be killed by then. So essentially, an infinite loop with no break instructions inside the body, so that means break out of the loop, it's typed as a bang, or it's typed as a no return, bottom type, infinite loop. So this loops forever. So let's just take a look at this example right here. Let c equals false, let v equals loop do if c break. Okay, there's a break instruction in here. That means the output of this loop is supposed to be the empty tuple, or you can type it as I32 if you were breaking something like that. And then this is like, let's say you don't even know the value of c. Okay, you can take a look at this in isolation. Let v equals I32 equals loop, right? You're looping, and then if c, break with 55. So the type checker can see, okay, there's a break inside the loop. Eventually it'll terminate, which means it's not an infinite loop, which means it'll eventually terminate to some value. So there's just an I32 here because you're breaking out of it. Now, what if this, right? Let c equals false. And then the type checker goes here, and let's say your type checker is doing some kind of optimization, some dead code elimination, and it deletes this line, right? And it's just ended with nothing. Okay, and then the type checker goes and says, okay, the loop doesn't end, which means this will be typed as that. Right? So your type checker, for it to evaluate all the types, it needs to perform dead code elimination, right? It needs to be able to inspect everything before up to the front. And I mean, this may seem hard, but it's actually quite easy. Now the reason why okay, I'll explain why. I'll explain why it's easy. Uh, Essentially, if you converted this program into a control flow graph, it'd be very easy to tell where things are unreachable, and when you get into a basic block, you can perform like these types of like these lattice stuff. So you can do sparse conditional constant propagation, going into a loop, and then you can find out immediately what code is dead and everything. You can do that all in one pass. So this is something valid that the type checker can do. They can do it. You'd be able to do this if you weren't in a tree, if you were in some kind of AST. You can do that. Something similar to this would be definite assignment, definite initialization, assignment analysis, or whatever. Let v equals something, if c, v equals this, right? And then you can be like, let c equals true. Okay, so v isn't anything. And then you can do this, let c equals true, and then that, and then you'll be able to like fill that in, and then delete that, and then you'll be able to tell, okay, v is always initialized in all places. Rust doesn't do this to the extent of constant propagation, but it does do this pretty well in cases where if you had something like a loop, v equals this, break, like you'd be able to tell, like Rust would be able to go over the it'd be able to go over the control flow graph and see, okay, v is always assigned in all places. So these two are basically the same thing. So basically, everything I'm trying to say is, I wanted more from the language, basically. So control flow can eventually create a value, right? And after optimizations, if the control flow doesn't branch out, it is typed as no return. Okay, so that's this kind of dynamic type related to optimization sort of thing. There's dynamic optimizations. So this is very possible, right? I did it since then. Where is it? Like 12 scaffold. I did all of this stuff trying to get type, like trying to get like types into it, so I could eventually try and type check this. But this comes with an issue, and I think I talked about it. I definitely talked about it on my last stream, where how if you unwrapped everything into a control flow graph, statement by statement, you'll lose the ability to reconstruct a tree, right? And what I mean by tree, I mean something like this: let v equals i30, well, like u8, and then 2 plus 5. Okay, you'd propagate the type up into here, and you'd propagate the type up into here. Simple, right? I've talked about this a billion times. It's my simple bidirectional type inference without values. So you just it'd be turned into this. So let's say 0 equals 2, 1 equals 5, v equals 0 plus 1, right? And then the type checker will go 1 by 1 by 1. But what you really want it to do is go to v and then up, because it can propagate those values. Okay, so so right now I have two different things I need. One, I need types dependent on optimizations I can apply on the fly. This is control flow based. And two, I need a tree sort of thing to propagate my types up. Those two are mutually exclusive. They're completely different things. The tree up values, you need an AST. For reasoning about control flow, you need a control flow graph. Those are two separate things. So what did I try and do? Right? What did I try and do throughout this whole time I was here? Well, essentially, I said to myself, get type checking work with a control flow graph. And that's what I did. I tried to get type checking work with the control flow graph for basically a week, and I spent a whole week on research. And what did I do during that research? I ended up creating 1, 2, 3, 4, 5, 6, 7, 8, 9 different documents. And then let's just go through the most recent document. Well, not the most recent, the best one that applies. I think I talked about. I think we were like here, right? I talked about how blocks can have block parameters, and you'd go from the bottom and go back up. So this is probably the one you're most familiar with, right? You'd have these kind of like blocks and things, but I think I'm talking about this one. This one. This is the one you're familiar with, where it has entry has these things, and then go to pattern, jumps to here, and then here and here and here, and that's it. Right, that's it. You probably understand that well. But yeah, LIR new. So I wrote this a couple days ago. That was a big mistake because eventually I went around and eventually came back. You'll piece it together by the very end, eventually. So this is just some like tree-based stuff. So eventually I was warming up back to the idea of a tree. Okay, so it's all about data flow analysis, completely nothing else. Data flow analysis given the source representation we have. So the IR, tree-like impl. Yeah, well, it's like tree. It's a tree IR. But during parsing, it gets lowered into a tree with high-level control flow semantics. After type checking, it gets lowered into a second time into a control flow graph. So I think this is just going. I think this is just going back to the HIR plus LIR. So this is tree and then converted into a control flow graph. So you have an intermediate step, which is that tree. So I think I was talking about this. And then I kept on going here and here. Yeah, and this is where I was like warming up to the idea of having a control flow graph mixed in with a tree. So this was something important. Here and here. This change semantics of let was something separate. Some syntax random stuff. Okay, so I didn't eventually talk about it here. Was it LIR, LIR even newer? Okay, so this is with a conversation I had with someone called Negate over at the Handmade Network. He's a great guy. He's very smart. Like, he's making his own compiler and everything, and he's got some really nice ideas. So eventually, I talked to him, and I figured out, okay, so if I'm in a control flow graph going statement by statement, top to bottom, and I need to recreate a tree going from bottom to top, how could I do that, really? So I'm going from top to bottom, right? You need to propagate information upwards. So I was looking into this, like, this lattice thing. This is with sparse conditional constant propagation. Specifically, these, like, certain things. Here, let me create an example. So let's just go back to the other example. Let v-ith u8 equals 25 plus 30. Okay, and how would you convert that? You just have an entry block. That's just assumed. And then 0, 1, 30, v equals 0 plus %1. All right, now instead of going backwards, instead of going backwards starting from v and upwards, you now go forwards starting from 0 down. So that's just normal. That's the normal way how you would go through the statement by statement control flow graph. So let's just try and find out how to bring the type of u8 down or bring it up. So let's just start here. Okay, what is the type of this? The type is a constant. So it's a const int 25. Okay, and what's the type of this? A const int 30. Okay, now what's the type of this expression right here? It's a const int, what's 25 plus 30? I should fucking know this. It's 55. Yeah. 25 plus 30 equals 55. So this is the type of this, essentially. Now, the type of v is known to be a u8. So now we perform unification. U8 unify with const int. Unify with constant. Okay, well, the resultant type is obviously a u8 because 55 can fit inside the size of a u8, and that's it. What we've done is, like, properly typed to this. It goes from top to bottom using these conditional constant propagation, like, constant literal types. It's like TypeScript, essentially. TypeScript has literal types. So this is going down, assigning these const int types. And then when you get to here, u8 unify with const int 55, and u8 wins, because this fits in the type of a u8. That's perfect. So we essentially have these typeless integers in the IR that are constants, and then they're flowing down to here. Now this solves the issue of types going upwards, right? We essentially have a general type going down and then making it smaller. Instead of having a small type already and then trying to fit them in all the way up the type. All right, now where this falls apart, essentially, where does this fall apart? This falls apart in many different ways. So, how do you type this? Let v this. Oh no, that's not right. Let v this equal this. Obviously, you can't like this empty type. You cannot infer a type. It has to have something in it, so you can infer it as like a array by 32. But you can't. This is empty. So this is impossible. You'd get like an error. Error. Can't infer. Can't infer. All right. So what's the IR that would be generated? So you have an entry block. %0 equals empty. V equals %0. Now the type of this is const empty array. Okay, const empty array. It's like a unit type. You can only have one construction of it. And then what you're essentially doing right now is unifying. Okay, this makes sense. You can do that instead. All right, so here now you have a const empty array going top to bottom, and then here you're unifying a array of U8, and then unify const empty array. That's what you're doing. All right, and then what wins? The U8, and that works fine, right? This works fine. You're going top to bottom easily. And this isn't really a place where it falls apart. Like, there's better examples, really, specifically with ones, if you want to decompose, let's say, a slice of U8 to something like this, right? Because its type would be a 3 U8, and then you'd have to decompose them and then introduce intermediary casts and everything. It doesn't really work. Well, it works fine. But really, my main gripe with this is that these integers aren't typed at all. They're not typed at all. And that's something I really don't want. Because what I would really want is this 25 to be a U8, right? And this 1 to be a U8. And this addition to be a U8. And the right, so you're essentially unifying a U8 with a U8, and it becomes a U8. This is what I want it to do, and you would only really know that if you propagated it upwards. So people would probably ask, right, why not just go with the method with the constant integers and the conditional constant propagation all the way down? And I say that because it introduces complexity where it's not needed, right? I want the IR to be completely concrete, basically. I want the types. I don't want to have these typeless integers, right? I don't want to fall victim to what I experienced in the V compiler, where I had these typeless integers and like I didn't even know what type they were, and I had to pass values up. It's a nightmare. It's a nightmare, and I don't want to relive that. So basically, there is nothing you can do to solve solve problems with like control flow graphs and type checking. They're mutually exclusive. Now let me show you an example here. Let v equals a do block with a label t, and then you're going to return 40, and then you're also going to break t with 20. Now I can show you this in the current compiler. Or can I not? Inst call. Is this experimental compiler too? Wait. Why is this inst call? What's parser expert? Oh, okay. I need to comment this shit out. Hold on. Alright. Alright. Okay. Now let me show you an example. Alright, let's take this code. Let's compare this to T is an I32. Well, it takes a nothing. I32. we'll just name this like f match on nothing equals that. All right, it's pretty simple, and let's run it. Oh wait, let me just delete this above. So the IR you're looking at right now is implementing this kind of thing. Well, okay. Well, let me give you some exposition on about what this thing. So eventually, I didn't want to end up like this. I didn't want to go this way using these U8 25, U8 third. Well, no, using the constant stuff. I didn't want to go this way because I just don't want typeless integers and typeless array literals inside my IR. It's not nice. Like, it's the worst, really. So what I eventually did after was LIR. This one. Okay, LIR. How many times are we gonna do this? So how many times are we gonna do this? A lot. So for every statement, I want to type check an assignment expression, perform reassociation, and perform const propagation and const evaluation. This is what the type checker is going to do it in a single pass. So, what did I end up with? And I ended up writing all of this. So, let me show you an example. So, f empty tuple equals a do block. You're breaking here, and you're returning there. So there's two places you can return. So let's run it. Oh, wait, there it is. Okay, so let's just have them side by side. Oops. Side by side. Function main.f takes in that, go to pattern match on this, and go to this pattern. Okay. So do entry. So this is the do block right now. Do entry. Underscore 1 equals 20, so you're breaking it here. Go to do exit, and then you're returning this control block right here with do entry and local. So this is what I eventually wanted this IR to be. So this is the okay, so this doesn't explain much here, but in here p do. All right, so obviously, you need to propagate the type of IR32 into the do blocks in here. You cannot do that in a control flow block way, right? Without calculating these like inner dependencies and these sort of things, right? It's a nightmare. So what you need to do is like you would need to find a way to propagate an up value, like hoist it like beforehand. So what if you could, while typing this, you could mark the break to evaluate to an I32 and then propagate that upwards. So you'd like reach it, and then before type checking the inner block, you would propagate them up. So it doesn't explain much, but anyway, just take a look at this. Let v equals do. brk with 20, ignore 50, and then brk with 60. Alright, so the do block introduces control flow as a value. We must nest it by creating a special do block expression that expands to the proper basic block representation when finished by splicing them together. So this is what the parser generates. It generates an entry block. Go to do exit, and then do exit, v equals a control token, and it takes in an entry, do entry, local is this local that we store to with the break. And when you reach here, you check, okay, what's the type of local? And then you essentially perform a splice. So this is the do block expansion. So it takes in this entry block and then changes the terminator to do entry, and then splices in the do entry, and then the do exit, we replace the v equals control token to the local variable here, and then this works fine. So go to do entry, underscore 20, underscore 0 equals 20, that's just brk. Underscore equals 50, you're just ignoring this value here. And underscore 0 equals 60. Then you're just putting this value here, the 6 is being returned. And then go to do exit. So this whole block is essentially no return. So trimming the IR, you'd eventually get that. And that is perfectly typed, because you know the type of underscore 0 beforehand, and then when you get to here, you can propagate the I32 up to here. So it's essentially like, this is kind of like a tree, but you're expanding it into a control flow graph. You're stitching in a subgraph. So it's nested subgraphs, and then you're stitching them together all the way down, right? And that's how I planned to do this tree, but control flow as a value sort of thing with these up values. It's a mess, but it serves its purpose well. It seems sane enough, right? So, yeah, when reaching a control value temp, so this thing, you must splice the control flow graph. So all terminators that dominate the current, they all go to the begin of this thing. So essentially you're changing in the do exit, entry is dominating it, so you splice out the do exit for a do entry, and you change the v equals control to v equals local. Simple. So we essentially represent everything as trees of subgraphs, and then we splice them together all the way down. And that's how you do up values. It's a nasty thing. So this IR was essentially merging control flow graphs with a tree, right? Trying to get the best of both worlds. Now, there's a couple of reasons why this works, and there's reasons why this doesn't work. This works great. In my opinion, it works fine, if not for certain issues. Now, there are certain issues. A couple of things. Index. Go to index operator. Where is it? Talk if. Is it this one? Just all the way down here. I think it's talk OSQ, open square bracket. So order of evaluation problems. This is to do with order of evaluation in the IR. Essentially, I won't go over the whole thing, but what it means is we can't solve this without introducing a tree beforehand. There's no matter how much you can do single pass, there is simply not enough. Because our language can have auto deref and all of these things, and the order of evaluation isn't really solved if you're unwrapping everything into a control flow graph with statement by statement. There's ways that I tried to solve it, and they work flawlessly, right? So if parser util, go all the way down to here. Okay. We'll go to the parser.h. So, when composing multiple expressions together, all expressions except for the last one are late use, which means they must be spelled to respect the order of evaluation with the presence of control flow. Is that how you spell presence? Wow, it's with a C. Yeah, I was freaking out. So, expression plus expression, late use and early use. Essentially, why there's a distinction between late uses and early uses is because you could do this. A plus B, right? That's pretty pure. Or you could do A plus if C, A equals something else something, right? You could mutate A and then A here. So what you need to do is, in evaluation of this, you need to write it to a temporary, and then evaluation of that, then you add them together, the temporary and the right-hand side. Because if you just did it normally, you'd end up with like A plus control flow that mutates A, which means this is completely invalidated before it even gets here. And these things are solved perfectly with a tree, with an AST, just by perfectly traversing whichever thing you want. But what it isn't, what it doesn't solve is, it just doesn't solve like things with arrays and all of these things where it just isn't defined, and especially when you have deref and you're assigning, it just doesn't work. All right, so I need to give everyone an overview essentially. So previous work. Region LIR, sea of nodes LIR, block parameter LIR. That's what I did the last stream. L value LIR was the last stream as well. The final LIR is this one. So this is where it works, and the future LIR, you can ignore this. So, all right. There's a reason why this stream is called the sunk cost fallacy. Essentially what I did was this. I gave myself a week. So from the last streamer after I implemented the type checker, I gave myself a week, and I was researching. I was researching into other IR stuff. So I went through this arc where I tried to look into sea of nodes. So I was looking at sea of nodes, and I was looking at block parameters. Okay, so I can do an IR with block parameters after my AST. I can do that, and then I got the good idea of, okay, what if I merge them together? I merge the control flow graph and the AST together and only have a control flow graph. Then eventually I go on. So that a whole week passes, I do just IR stuff. Alright, and I understand how the IR works. And alright, and then after the end of that week I do a stream and I try and implement type checking. Alright, and that was, I think that was stream 10? Well, okay, no, that was stream 12. That was stream 12. And I think it was stream 12 or stream 10, but I'm pretty sure it was stream 12. Essentially, I spent a whole week researching IRs. This was still in the stage where I still had my AST. So let's say I want to go from my AST to my lowered intermediate representation where I can do data flow analysis. Two separate things. AST is an intermediate step. We go to the next step. So I spent a whole week on researching what are the best IRs I could use. Alright, so a whole week passes. The day after, I have an idea, right? So this is the second compiler that I've made. The first compiler, the predecessor, this is called Experimental Compiler 2 for a reason. There's a repo on my GitHub called Experimental Compiler. It's just a simple, non-functional language at all. It's just an imperative language, not functional. It goes top to bottom, and it doesn't have an AST. It only has a control flow graph representation. I was mirroring it after Zig's AIR. So, and I was like, okay, I was looking. All right, I don't want an intermediate step. I don't want a HIR. How can I just go from tree to control flow graph? All right, how could I do that? All right, so I implement it, and then I start trying to do type checking. Okay, this type checking doesn't work at all because control flow graphs, they have an unwrapped tree representation. I don't have a tree anymore. So I go through that stream. I go through that stream where I try and implement type checking. I go through the whole thing. I can't do it. It's just impossible. And I spend a whole week trying to do type checking. I make multiple different kinds of IRs, all that work, and then they all kind of introduce some kind of tree nesting back into it, and I end up getting back to here. I end up getting to a language that has a control flow graph plus tree. Hi chat. A control flow graph plus tree. And I get to here now, so I've wasted 2 weeks, essentially. Right? In the grand scheme of things, I have furthered myself so much just from these 2 weeks, right? You can think like, since I haven't really progressed on the compiler, it's all a loss. But I don't consider it a loss because I've learned what works and what doesn't work and what to do in the future. So it doesn't take a genius. It doesn't take a genius to figure out that you need a tree. You need an AST before you get to anything lower. It doesn't take a genius to figure that out. But it's just these sort of specific intuitions on like deeply why, right? And then it goes even further than that, right? How do you implement data flow optimizations? I mean, during that 2 week period, I learnt about tree walking. Okay, what is reversed post order? What is topological sorting? I learnt a decent chunk of things. So I don't say I wasted it. In fact, I implemented that inside my type table. All right, what I'm trying to say is I spent 2 weeks not furthering the language, but furthering my knowledge. I don't know what I'm trying to say. Eventually, the stream is called the sunk cost fallacies because I spent too long trying to do something that doesn't work. Trying to spend something that doesn't work. So I spent 2 weeks on that. And hey, I don't have 2 weeks. I have 1 week. I got school in a week. So, all right, I got to pivot. So I got to pivot. I got to go. And also, there's a reason why I haven't been uploading as well and I haven't streaming, is because I said to myself, you are not going to do anything until you get type checking done. and that kind of backfired because type checking is impossible. This sort of thing. Yeah, Zakazaka says AST time. Yes. Yeah, I yield. I give up. I give the fuck up. I'm like, man, I feel so dumb, but it was needed. It was needed. All of this information that I was doing, it's gonna further my understanding. It's gonna make things even better. So, I need a pivot. No, I need an AST. Zakazaka says, I also tried your AST approach and I realized we can just encode AST in it. You mean encoding the AST into the control flow graph? Because that's essentially what I'm doing here. But it also doesn't end up working out because I need to find out like all these specific order evaluation problems. There's only so much you can reconstruct inside control flow graph statement by statement form. You need an AST. I mean, I've literally exhausted everything. You need an AST. Like, I tried to be smart. And I got humbled. So, and especially your language may be simpler than mine. Your language may be simpler than mine, which makes it possible. But my language has like types and methods, and it has like auto deref, auto call. It has these things like it has closures. It's a very complex language. I eventually want to end up right. It's quite a complex language. It's with simple principles, but they're complex. So it really wins to make an AST. Okay, I really should have trusted myself in the beginning, right? But lesson learned, and I did learn a big lesson. Anyway, I've got to pivot, right? So I have all the code in the world, right? I have multiple different versions of my code base from different commits. All I need to do is take an AST and the LIR and split them apart. So essentially I have the HIR and the LIR. And then I convert the HIR into the LIR, and then we're done. Right. Yeah, so I need to do AST now. Let me explain the way I want to do it. So this is HIR plus LIR. This is the 10th document. And hopefully the final document. Alright, so top and bottom are a bunch of ramblings because I append to the top and then I append to the bottom, and then the most important stuff I put in the middle, which is stupid. But this is the way I note take. So, compilation strategy. Parse into a HIR. Assign symbols to a global tree. All functions will have their own HIR attached to their symbol. So, let's take a look at this. Symbol function HIR LIR. Alright. So, iterate over all global symbols in reverse post order. So this is just some specific things I talked about, I think, last stream. Essentially, I want to iterate a symbol before I want to type check a symbol before its parent. So this is just some reordering stuff. Alright. For every symbol, so every symbol up to this point has a HIR, a true representation. So for every symbol, construct an LIR. So you're constructing an LIR here. Expand closures recursively, perform optimizations, improve invariance. Also, expand macros from the HIR into LIR. Good. So, the LIR is fully the LIR, so up to this point, the HIR is fully typed. And then up to here, the LIR is constructed. And then after possibly perform whole program optimizations, and then lower LIR into some other assembly-based thing. So, how this compiler works is the whole system-wide thing is a symbol. The whole program writing is a symbol. If you have a function main inside the main module, it's called main.main. This is the Go and V-like module system. I really like it. I really admire it, so I'm using it. So this is the global symbol, main.main, right? And inside main.main is a function. So this function has a true representation and an LIR representation. So what we do is we follow these steps. So parse HIR type, parse LIR type, done. That's it. That's how I'm structuring it. How I had it before, though, when I still had the HIR, I had like modules with symbols and then functions. And then, oh no, I had HIR globally. I had a global HIR and then global function, global symbols in a module. And then I had like a whole thing. This is a horrible mess. So a good thing about taking the 2 weeks off is that I was really able to standardize exactly how I wanted everything. So, what I want to do this stream, I have a lot of code that I have to write. I won't get it all done this stream, but there's a couple things that I'm going to do. First, I need to bring back the HIR. I need to bring it back. Okay, I need to, like, I'm in big trouble if I don't bring it back. So this whole stream is about me bringing it back. All right, second, that's probably all I'm going to get done. But if I had more time, second, I'd fix the symbol resolution stuff. I'd be able to define types. So now in a symbol, you can have a type. I want to be able to define types as well. And then after, I can do the LIR. And a good thing about that is I essentially have a fully finished LIR and a partly finished HIR. So I'm done, right? I'm basically done. All I need to do is bring them back. I need to resurrect them from 2 weeks ago. So, let's bring back the HIR. All right, I talked for 40 minutes. You know, all right. Let's do it. So let's take a look at the codebase right now. Prometheus, time to get revert. Well, it's more complex than that. I'm probably gonna have to open up 2 different VS Code instances on 2 different folders. So let's just start by doing that. Let's do a rm cd git. I want to rm the old experimental compiler 2.2. That's the like second one. I want to git clone from what's git work tree? Never heard of that. Well, I think you probably mean like just opening files and different things. It's always been easy for me to open 2 different editors with 2 different things. I don't know. 2.2. Alright, it's just how I've done things. Like this is how I've worked on the V compiler. I just open up 2 different branches and 2 different editors. Alright, now let's go to a really old commit. Yeah, it's easy. Just yeah. Okay. Well, I'm stupid. I did a git clone with depth 1, so I need to git fetch. I hope that's right. Is that right? Let's git graph. Okay, no, git fetch. Is it all? All? Okay, all. Just bring it on. Is it? Okay. You know what? Yeah, I don't know anything about git. Okay, I may use git all the time, but I don't know. I don't know any of them. Let me just git clone it again without the depth. Git's an enigma for me. I only know 3 commands. Right, experimental. And God knows if I have to do a merge, how that's gonna end out. If I do a merge, I just use my IDE, my fancy IDE that does it all for me. All right, let's git log. So this is the initial LIR API. So this is where I had my HIR and everything. My desugaring. Well, let's take a look at LIR right now. So this is like the humble beginnings. This is like in stream 10. Okay, so here, this is where it all went to shit. Parser plus LIR. Start complete migration to LIR. Block SSA instead of tree HIR. Tree IR. So this is where I fucked everything up. So Prometheus says I use Vim daily, but every time I need to merge, I open VS Code. Well, yeah. So, Chat says, what was the failed experiment? Type checking without the AST. Type checking without the AST, exactly, that's right. Type checking without the AST. I thought I could do it. In reality, it's not just the issue where you have graphs, when you have a true representation unwrapped into statement by statement, where it's no longer in a tree anymore, that's an issue that can be solved. But there's other issues, right, that you can't do in a single pass. Things like L values and spilling and order of evaluation. It all gets hard. And my language is complex. It's not a language like C. You could easily do this in C, but my language has closures. It has methods. It has auto deref. It has like fields and all these specific things, and you don't know what an L value is. And the thing is, if I want my language to be a language, you need an intermediate step. And Zakazaka says it sounded smart, but it wasn't after all. Yeah, it's right. Like this, it's the way I do things. Really, I try to go for the hard stuff, and then like I don't know, like in all my compilers, I just try and ditch the stuff. I mean, even yeah, it was a dumb idea. It didn't sound dumb, but the specific issue about statement by statement going up in a graph, I could have easily computed some kind of dominance tree reverse post order to go over the whole thing and type check properly, or this work list, a monotone framework, and get everything with all the up values perfectly. But the issue is more deeper, things you can't do in a single pass, because that's what it was, a single pass compiler, essentially. You know, my language is complex and it needs an AST, right? It needs it. It absolutely needs it, especially when you're gonna add like attributes to expressions, right? Right. I mean, there's a reason why Rust and all these other languages, right? I tried to be smart, but really, the smartest way is to use an AST, right? So right now I have the AST from before and I have the LIR right now. All I need to do is mix them together and do some lowering separately, and I think that's it. So this is in the second clone. So let's take a look here. Start complete migration to LIR block SSA instead HIR tree LIR tree IR. So in the parser expert, I create something new entirely. Oh yeah, so this is like here. So instead of my R expert and then talk true, you construct a new inst value with a bool literal and break. Yeah. Mass expressions. When wow, I did all of this. I did loop up to here. 12. Implement scaffold. What did I do here? This is for type checking. So I implemented like some type checking, some basic type checking. Yeah, this is the reordering of symbols. Okay, so let's switch to here. Let's switch to here. Check out. Okay, great. So we have HIR. So my code base is getting big. It's getting really big. And I have 1, 2, 3, 4 different C files with no extension, because those are my old implementations of the type checker. It's funny. All right, so let's do some renaming. So what I want to do is I want to put things in an old folder. Okay, this might be the most stupid way to do things, but let's just do like old. Okay, fix later, old, and let's just move all this shit because I don't want to see it. Let's just go check ansi.h. Or is it check reorder can stay because it has to stay. Check unify can stay because it doesn't use anything. So this can go. You can move. Check.h can stay. HIR has to move. Parser has to move. Parser expr util and the parser itself has to move. Parser.h has to move because I'm going to be re-implementing that. All right. I can go up here, the old folder. There it is. Okay. So let's just bring back the old code. Let's see what we can do. Let's see how we can edit it. So let's go to HIR node T. Let decal lambda match do block loop if assign infix postfix prefix deref adder and all of this stuff. So now there's a question that I also there's something that I also want to solve. let A is a none, let's say like a none I32, right? And we're properly typing it as such right here. All right, and then we perform a match. We're matching on A. This or none. All right, and then we do stuff. Dot, 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 dot. Do you want to name resolve while parsing or later on? I'm always resolving names while parsing. I'm always resolving names while parsing because that's something I can do and that's something I prefer to do. Okay. Let A equals I32 equals none. Match A. Nothing A. None. Alright, so. During type checking, this holds. So the HIR will go over and type check the whole thing. Actually, let's remove this branch. So we've removed the branch. This branch is not exhaustive. It'll raise an error. Well, it will raise an error in languages like Rust, but I don't want it to raise in this language because this is going to be statically determined. So let's say this gets typed into a HIR. So let's say I have like a node let, right? And then you have the next one, node match. And then inside that you have all of the patterns. Okay, so we only have one pattern. So we perform type checking. We check, okay, this is here and then this is a valid case. Good. We don't check any exhaustiveness. No exhaustiveness is going to be checked. We only check exhaustiveness inside the LIR. Let's say we have A equals none, and then we have a go to pattern A, and then none equals go to something. Okay. So we don't perform exhaustiveness checks here. We perform exhaustiveness checks here because that's a data flow problem. So, this is what I like. This is where I won't check certain things during type checking. Also, things like let A B equals ... There won't be an explicit let in the HIR. There won't be a let node. There will be this will be desugared into a match match ... A B yeah, with like a single thing, like, and then go to next entry. This will be desugared into this, right? So when you get to next, these variables will be set, and then we can perform data flow analysis. We can check like we can perform data flow analysis and check like, okay, this match here, is this exhaustive? Well, you'd have to check. Well, a better example is this. A better example is like let none equal something. That's a better example. Like you need to perform data flow analysis to check if this expression is none. Essentially, pattern matching is something that can be solved beyond types. Like you need to prove that the pattern match is fallible and not fallible. Rust has this intuition of fallible and non-fallible like let bindings, ones that can fail. So if we can statically determine that, we can provide better guarantees. This is like, there's certain things I will check and certain things I won't check, and there's certain things I won't include in the AST, and there's certain things I will include in the AST. Now, let's just start doing it. Okay, so this all.h is getting really long. It's like, it sucks. So this is what I kind of want to do. I want to have an all.h, which is included by everything, and then I just have like a, I don't know, like lir.h. I want like people to import things where they needed. Yeah, I really like having everything all in one, because that's what the tiny C compiler does, and all these certain things is because it avoids circular dependencies, which is really annoying, because when I was building the first compiler, the experimental compiler 1, I got a ton of circular dependencies, so that's fucking annoying. Because they all depend on each other. So I think I'm gonna split the all into like multiple different things, like the LIR and stuff, but just respecting circular dependencies and make sure I don't generate that, because this is a big file. Like this is a long file. So I want this LIR stuff to be separate. So let's just do that right now. lir.h. And just take all of this out. All of it out. And just paste. And then in the top, we'll just do a include all. And then here, we'll just do at the bottom. Include. Alright, what a silly fucking... Okay, well, let me just do a... Pragma once. Alright. Someone made fun of me in a YouTube comment for using Pragma once. I think he's a fucking idiot. I think he's... well, I don't think he's an idiot. I think it's 2024. Alright, you're allowed to use Pragma once. Don't create a big if-def chain. Save the compiler some time and use Pragma once. Yeah, it's 800. You know the original parser. Oh fuck, this is even longer. This parser is 2,000 lines. There's a reason why I split the parser into parser expression, and parser util. It's long. It's fucking long. Yeah, so things get to 2,000 lines here. Alright, so we have the LIR into one thing. Now, let's just do the types and symbols. Actually, no, this is going to be separate. Pattern, so all this LIR stuff is gonna have to be moved. Yeah, parsers in C tend to be huge. Not really. Not really. I just have a really... The reason why this parse is huge is because this is a single pass compiler. This is akin to generating, like, machine code in one go. Right, because I'm generating like a control flow code. Also, most of this is just comments. Like sometimes I just have something big. I need a big thing I need to say, like this thing. Oh, that's just not comments. But here, this is all comments. All the way up here this is all comments. Here, this is a huge amount of comments and everything. You can check out bun.jsparser.zig. Yeah, I've used bun before. It's great. And it's open source as well. It's probably huge. I don't doubt it. Yeah. JavaScript's insane, especially it probably has some ambiguities as well since it takes from C. All right, enough talk. Let's move all this LIR stuff. So. And it shouldn't be named LIR SIMT. It should just be named symbol. So I'm gonna rename this. There's no symbols are gonna be their own standalone thing, part of the LIR and HIR. They're gonna be like their own thing. So just a SIMT and just LIR proc, block, term, pattern, statement, all the way up to the top. L value projection invalid. Oh, yeah, local. Buford 0014. Hi, welcome to the stream. Alright, so you're all going. All of you are going. All the way in here. Okay. Yeah, that's a lot. Redefinition. Alright, TI guard, type guard. Do I use this anywhere? Buford said, I've been watching your videos for some time, finally catch you streaming. Yeah, thanks for showing up. You can join the Discord if you want to know exactly when I'm streaming. So there's some types. Alright, LIR process and LIR check. So I want to rename this a separate thing. So I want to have a just name it like compiler process file. Yeah, that sounds about right. I think that's fine. So I can rename that to something else. Compiler process file, or like parse. I'll just name it compiler. All right, and then LIR check, compiler check. Yeah, I mean compiler check. And that sounds nice. That sounds nice to me because we're doing more than just checking. We're also doing optimizations. Compiler check. Alright, so this is the SIMT, and we're going to rename the reference to SIMT. So this is a U32 index. We're going to rename that to just our SIMT. Alright, no more LIR branding. This is the file system. mod PTR, file PTR. Oh yeah, this is where I stored HIR scopes. Silly. Oh yeah, this is from Zaka Zaka. U32 start, U32 end is better. So I need to fix locations. There's 16 bytes. I mean, if you like, that's 16 bytes. I double the size of my nodes by including these locations. It's crazy. All right, T info. I never really liked the name of T info because actually I never really liked the name of T icon. Actually, I'll rename it later. Alright, types, tokens, and I just list all the tokens here. I should probably keep this in a separate def. Talk.def. Actually, def.h. Yeah, I'm gonna put all these things in that. Delete this comment. No float literals and int literals, and those aren't in the language anymore. Alright, going all the way up. Alright, delete. Good, and this all can go here. Alright, and def.h, you just include this one, so. Back one once. Good. Alright. Let's find where all the errors are. Unknown type name LIR proc T. What's this? Oh no, this is. See, look, circular dependencies again. This is bullshit. I hate C. Like I don't. I love C, but it just has so many shit like these like rough corners and everything. Yeah, unknown type name. I mean, actually, I don't know. I mean, okay, now that works. Okay, well, it's gonna get worse in the future. All right, so let's have a function. So this is how functions are going to be represented. They're going to be represented as these global things. So function t or proc t. That's fine by me. Proc t. All right. I'm going to type def that. I don't even keep my type defs in the right place because they're just so annoying to keep track of. All right. Yep. Incomplete type. Well, that's funny. That's funny. Nice joke. All right, so the proc can have a LIR and HIR. So HIR expert. List of expressions. So, what I also want to do, I want the HIR and LIR to share, essentially. I want them to share variables. All of these locals, they're gonna end up sharing. There's like no way around it. So, this is gonna be moved. Deleted. So a proc has a list of not LIR locals, but I think local is fine. I'm not naming it LIR local. Local is fine. I'm going to change the LIR locality to R locality. All right, so the LIR and the HIR are sharing. They have to share. HIR expertise, and then let's get the HIR back. And let's just move that here for padding. All right. All right, that's even better than before. Now, let's get the HIR back. HIR.h. All right, so the LIR here. I'm not going to copy everything, but just the header. Okay. So, oh yeah, inside HIR, inside LIR, we need the where's it? Local T. Yeah, so local T. Yeah, these are coming out. These are going into all.h. All right, unknown type name. What? Oh. So. All right. Let's do a proper. Let's create the LIR, the HIR. So the HIR is basically a list of expressions, just really how I remembered it. It's pretty simple. It's like one of the simplest things in the world. I've reinvented the parser like 5 times over. All right, so there's no scopes in this language. Like after I finished the HIR, I removed scopes. I introduced this like scope stack thing. So all variables are properly created beforehand. All right, so the HIR and the existing LIR follow both a tree-based system. So we can just copy from there. So we don't need a let decor. We don't need, okay, we need a lambda. We need match. We need a do block. We need a loop. If is explicit. Node assign is explicit. Infix. And no, we are not desugaring. Prefix. Deref. Address of. Index, slice, integer literal, bool literal. What else? Integer literal, bool lit, var. We'll move this to the top. Node. I'll name this to local. So yeah, no, all of these like unresolved locals and symbols, these are gone. These are gone now. There's only this local and symbol. Okay, node cast, node call, node tuple. Node tuple. Yeah, unit, array literal. Okay, you're going up to the top. And then tuple lit. Okay, these aren't really literals. Okay, break, unit, break, inferred, break. So there's 3 different types of break. That is stupid. Okay, we're not doing that. There's only one break. Node break. Always bang. Okay, node undefined. Can be let go. I can go for now. Evaluates expression, possible effects, discards return value. I remember doing that. Node size of type. And node tuple field. And then just node field. Okay. Node field. We have a type, location. What else? So we have a R local T. It's the D local. There is no local unresolved. There is only an R symbol, so D symbol. Yeah, HI node T voiding deref. Yeah, block ID. There's lists of patterns as well. Okay, so we need patterns to be separate. Patterns aren't really an LIR thing anymore. Alright, and then yeah, we can take this out. Put this in the full thing. All right, pattern T. Zaka, what's the reason for a single node structure? Depends on what you mean by single node structure. You mean the fact that I'm storing everything. Oh, instead of typed pointers forming a tree. What do you mean? Because isn't everything already is like typed essentially? I mean, you don't really know the the backing pointer. This is supposed to be like a sum type over all of this possible tree states. All right, HIR LIR is going to be completely separate. So there's no. I'm going to go over these one by one. I need 2 HIRs. Union access would be less type safe. Ah, okay. So you mean what people do when they extract this separately and they go like they call like a function or macro. They go like uh is size of. And then they go node size of. And then they get a pointer to node size of, and then they use that direct pointer, so it's perfectly type safe. I think I know what you mean. Just have ASC with lists of decals, etc. Yeah, you're right. I mean, I could go that direction, but I don't know. I don't know. It's all gonna be cleaned up. It's all gonna be nice when I make the bootstrap. When I finish the bootstrap compiler, it's like it's a nice thing to have, but it's just more boilerplate I need to write. It's more boilerplate I need to write because I need to write the macros to access, and then I need to change those I need to add and delete those macros whenever I add new things. So it's just quick and simple. I mean, I haven't had any issues yet. All right, so let's go one to one and update all of these things because they're definitely old. So integer literal, local is R local, like this reference to a local. Symbol is reference to a symbol. Voiding deref. Type T is size of. A tuple field is just that. So it's going to be a U16 because I don't want people to have like int max fields. All right, index. You have an expression in index. Dslice. Left hand side, right hand side for assignment. Address of ismut. D symbol unresolved. That doesn't exist anymore. D symbol doesn't exist anymore. Node postfix and prefix. What postfix types? I'm not aware of any postfix expressions in this language. Oh, plus plus and minus minus. Okay, so what would be better? What would be much better? No. Postfix would be instead of a top kind, we should do another enum kinds, and then we're just gonna do node kinds inc and deck. That's easier, and then we'll type this easier. U8 enum. This is a great thing I love about how you can use these enum colon U8s to specifically type these enums. It's like you're in C++. I think it's like a new extension, but they're adding it back in C23. Plus plus and minus minus is a pain to deal with for everyone. Like adding P plus plus and then like P see what I'm having in my language is I'm only having this. I'm not adding the prefix plus plus. I quite like the plus plus. I think it's fine. I think it's fine. Especially when I want to do something like P plus plus deref, because that's a common thing I do in C. It's not safe at all. Like it's not safe. But that's a common thing that I do all the time. P plus plus dot something. But I'm never ever gonna have this plus plus p. I mean, that's just disgust. It's not disgusting. It's like it's a relic. of C, really. I don't want it anymore. Alright. Okay. Fury virus. I'm building this for an existing compiler backend. Also, welcome to the stream. No, I'm gonna write my own compiler backend. I'm gonna write my own one. Yeah. I'm gonna write. This is a completely self-hosting, my own, well, completely self-contained compiler and programming language. So it's gonna be. I'm gonna create my own backend. I've written code generators before. I feel like I could create. I could probably get a good stab at it. Um, it's not that hard to make a good enough code generator. It's hard to make a good code generator. I feel like I can make a good enough code generator. All right. I eventually want to use this language for embedded development and use it for WebAssembly, and this language is going to become my C replacement. It's a language with everything I like in it. So it's gonna replace all my uses of C. It's gonna be like my Zig, right? There's things I don't like about Zig. Well, there's not much to hate about Zig, but Zig doesn't have closures and all these functional stuff, and the syntax leaves up a lot to be desired. So yeah, have fun with x64 vector extensions. Yeah. Yeah, that's a nightmare. That's a nightmare. I won't get floats in until a while. But I think I'll be fine. I mean, in reality, it's just knowing what instruction to use. It's a pretty simple concept to grasp, but it's just knowing what instruction to use. Okay, so we have no scopes in this language. We have no scopes. Lambda. I'll do lambda last. I'll probably figure it out off stream. You've mentioned embedded. Are you going for ARM first? I'm going for RISC first because I have a couple RISC boards and I want to make my own music player. Right? I want to make. I can listen to a lot of music. I want to make my own music player. Completely RISC. So completely my language, my RISC, everything. My own audio formats, my own like database stuff. My own. I want to end up creating my own like music aggregation thingy, like so scraping music off YouTube and stuff, like akin to piracy. But I pay for Spotify Premium anyway. But you know, everything I do is basically I want to create like my own stuff, right? My own stuff. That's why I'm making my own language and my own code generator and everything. And I'm going for RISC first. That's my answer. Piracy, yeah. All right, dematch. So no scopes. Pattern is going to be just pattern T, list of patterns, list of expressions. All right, let deco is a single pattern, a single expression, right? I don't know. All right, and then decall. Okay, so calling in this language, it's like represented in a functional way. So you have what's it called, unary or unary functions, or their arity is 1, so they have all functions take one value. It's basically a curried representation. It's I don't want to bloat up the IR, so I'd rather just turn everything into a f and then a array. So it's like args s to indicate it's an array. So no more am I wasting memory by creating these individual tree cool node thingies. There's no need for that. Alright, tuple is a list of elements. Arrays, list of elements. Break is an expression and the break ID. And if is that. Alright, simple. Simple. Alright, what's the issue here? Unknown type name, HIR expert T. Oh. And change these nodes. Type def. All right. Okay. So we're gonna have to redo the parser. That's essentially the most annoying thing. So there's an oh god, it's so annoying. Parser.c. So this is the LIR. This is the entry point. So all.h, and then we're gonna have a p context. So this is the parser context, which is a global variable because I love global variables. Buford says, how long have you been working with language compilers, etc.? I worked on C jobs on and off, but never tried that. I've been working with C for 2 years, on and off. I'm 17. I don't have any hobbies except this. I go to school, right? I'm not in uni. I have a lot of free time. So, compilers piqued my interest. I've made a couple compilers before. I've tried to make these like game engines and I don't know, just lots of fun stuff. And I've written blogs and everything. I don't think many of my subscribers, many of my like viewers have seen my website. But I used to write blogs and everything. Um, uh, you know, right now I'm pivoting to this more like YouTube and streaming thing because I want people to know who I am. Right? I want to meet people and interact with the community and like learn more things, and learning more things you need to talk to people. uh yeah, so I've been working with C for a long time. Sorry, I went on a tangent. Yeah, it's 2 years, 2 years, 2 years, 2 years. So I have the ability to do that because I have a lot of free time. But not anymore because in a week I'm gonna have my HSC, and if you don't live in Australia, what that essentially is the big test that lets you go into uni. All right, let's create a thing. Really, 2 years in this level, not just impressive. Congratulations, man. Thanks, thank you. Uh, yeah, it's just like when it becomes your passion, you can really develop like a liking to doing all these things. Because this is really what I value. It's like breathing. It's like breathing to me sometimes. All right, so we have p context, p import, p proc, p scope, and p block. So these are all the intermediary stuff. So here, so let's just copy all of this. All right, so this is let's say you're parsing a do block. So you have like do this, and then you have, yeah, so when you're inside a do block, it'll push this on top of the stack, it'll push a p block, t, onto the, like the stacks of do blocks. Yeah, the amount of free time in high school it's unmatched, really. Well, before like computers and everything, I used to be heavily into math and everything. Like, I used to do math for fun. It's like, it's the dumbest thing. Like, I feel like I just take on these hyperfixations and these certain things. Like, I don't even think I used to do 3D as well. I used to do like I don't think anyone's like seen L-M 3D. Wait. Oh no, I don't even think these things load. Did these load? Oh man, I used to do like 3D. I used to run an Instagram account where I did 3D in my spare time as well. So like uh you know uh, oh that's right. This is how I like used to spend all my time really. Is like my hobbies and everything. This is what I find fun. So throughout the years, it's just like math, 3D art, and like computers and stuff like that. And then I write blog posts, and and then now I'm doing streaming and YouTube because I think that's just a way to like further my everything, right? Yeah. When I was your age, I used to make mods for games, and that was it. Never even thought of C of stuff. Didn't program for 3 years. Yeah, no, it's like I went through something similar. I mean, it's really quite sad the amount of times I've played video games. Uh, I can explain to you the damage. It's essentially I spent 10,000 hours on video games. Going off the top of my head, I have 1,200 hours on Terraria. I have 700 hours on Escape from Tarkov. I have 1,000 hours on CS:GO. I have 800 hours on TF2. I I have like 400 hours on Unturned. I have like 300 hours on Terratech. I don't play Dota 2. Uh, see, these things like, uh, yeah. I don't know. I went through like these phases in my life where I just played so much video games, like fucking crazy. It's mental. And eventually I stopped myself. So I moved on from video games, and then I did some 3D art in between that. And then I moved on. Okay, all right, this is what I really find fun. Computers and computer science and learning and computer architecture and just code generation, programming language development, code generators. I mean, that's what I find fun. All this stuff. Like, I read papers for fun in my spare time. If you open my like Firefox mobile, I've got PDFs open of like a Cliff Clicks paper on Sea of Nodes, and I was reading like the LLVM paper, and it at the end of the day, it's just really passion. It's just passion, and when you have free time and you put your mind to something, you'll just do that, right? Like, I can't believe I spent 10,000 hours on fucking video games. It's crazy. I don't even have Steam installed on this computer anymore. That's just, I think I spent like thousands. No, I didn't spend thousands. I think I spent at least $1,000 on video games. It is fucking crazy. Buford said, do you have peers around you who understand this stuff? When I was in high school, nobody cared about the work I do. No, I have no one that I know. Well, no, that's not right. I know people. I know people online. I don't have any online friends because that's just not how this is not how I work. But I know people online, and I speak to people online, and I respect people, and like I talk to people and things like that. So those are my peers, essentially. Those are my peers that do the same work that I do. The people that I know, like my friends and like people at school, no, they're not particularly interested. No, they're not interested. They're not interested at all. So I can't relate to them. But I mean, what they did relate is to like my 3D art. I think that was interesting. Yeah, me reading 5,000 pages of x86 guide fueled by pure passion. Yeah, that's right. I mean, there's a point in my life where I read the fucking whole UEFI specification. I tried to make an operating system. I mean, that was like my low point. That was my low point. Don't read the UEFI specification. That's the end. That's the end. There's no coming back from that. All right. So this is the P block. So it has a you include all.h. Always BRK, and these are the reference to the blocks in the control flow graph. So we don't need them anymore. Immutable immediate local to store BRK. No, don't need that anymore. Okay. Imports, and these are the scopes. These are my scope entries. Great. So PS local, debug reference and symbol. Okay, and this is my parser context. It's the simplest thing in the world. So you have a pointer to the start, pointer to the current character, pointer to the end, and pointer to the last new line. I mean, what a great way to waste 32 bytes. I could have gotten smaller, but it's simple. It's simple as it is. Yeah, I don't mind it. All right, okay. Well, let's just get the rest of these functions. The functions that aren't LIR dependent, LIR dependent. Okay, so extern key, and then we need block locate, pattern, pmask, scope, imports, type, unexpected, check, pnext, plax. Good. All right, and all of those things. Okay, pexpert. This is the result of parsing the expression. So I'm not going to use the specific LIR stuff. LIR stuff. pexpr. Where is that? Is that in here? Oops, pexpr. All right, so it can it takes in a scope. There's no scopes, so we don't need to take in that. Takes in a scope, precedence, config, and previous expressions. So we don't even need any of those. We only need the 3. So this returns a HIR expert T pointer. Great. Actually, LIR, we need to represent HIR. To-do. What's the issue here? Let's move that to the top. I hate cycler dependencies. Need to represent let. Yeah, because there's no point of statements. That's just a note to myself after the stream. Okay. All right, what else do we need in the old parser.h? All right, p expression, p no return value, we don't need that. P extra spill local, L value, late use and early use. So this is just like some like single pass compiler stuff. I should write a C compiler. I should write a C compiler that's like a front end to the back end in this language, and probably make them interoperate. That would be really nice. A first step would be a convert header files to this language declarations. Okay. All right. So that's it. That's all the parser is just called pexpr a million times. Silly. Okay. Then we're going to take from the old parser right now. So this is the thing that we need to call. Compiler process file is the very start. It just constructs the p context with a start, end, and new lines. All right, and then we just call p top statement a million times. So functions, constants, globals, types, attributes, and so on. Right, that stuff can go. Alright, then we're calling pfn, which is p function. And then we're just copying all of this. Do people do interning of types? I do. But I don't know if everyone does. I know that V doesn't, because it has its own separate thing. But I do, and I can show you. It's pretty simple. All it is, the API is type underscore. The API is where is it? Come on, where is it? Here. So we have this struct called the type info. So it stores all this type specific stuff. And then what you'd do is you'd call type new to take in the type info and return a type t. And what it would do, it would perform interning of this type info. So when I go to type new and type, the defined type can easily get ID, but sized arrays plus slash pointer combinations are not intuitive. Sized arrays. You mean ones with like indirections? So how the V compiler does it? I think I wrote like a nice article on this like a while ago. It's a U32, and what's packed in is a nr muls and then IDX, and then flags. So essentially, you can have a type which is a type IDX, and then has the amount of nr muls, which is just these. So how it works in V is like there is no interning. You just have the type, and then you just add the amount of muls. How I do it in my language is I have this thing called type new inc mul. So it just increments the amount of muls. It's defined here. It's defined as simply takes in a type t and types of bool is mut. So it constructs type info, type equals type pointer, d pointer ref, and d pointer is mut, and then calls type new. And what type new does, it runs over all the types backwards. It runs over the types backwards because you'd like have similar types. Similar types would be created together, so the interning will be quicker. In best case, it would be quicker. And all it does is run backwards and goes compare type info. If they compare correctly, return the old value and discard the type info at the top. And then all this does is just check for equality. So I represent pointer types as their own type creation. So separate. So what V does is just you take a type and then you add the amount of muls inside its bit representation. And what I have here is I have a completely distinct type t, which is, let's say it's a reference to this type t, 0, and then a completely different type t is a reference to this. But when you take a look at this, type t1 is built up of 1 is type of pointer to type t0 because the types are interned, right? That's how I represent things. It's pretty smart. It's simple. It's very simple. I created this type system months ago when I was working on a different compiler. Yeah, sized arrays and pointer combinations, they're just separate type infos. Like you're just creating a whole new type. The only good use of interning I can see is collecting monomorphized combinations. Well, there's many good uses for interning. Yeah, the monomorphized stuff. Yeah, well, yeah, for your project, comparing types is cheap, but then you'd have to like recurse if it's like the amount of moles and stuff. Worst case it's slow, best case it's really fast. But comparing types in this, it's essentially integer equals integer, which is great about interning. Integer equals integer. I intern my types and I intern my strings. So it's just integer equals integer, like comparison. It's super quick. I store muls in a single U32, and I assume that's with the type. Yeah, that's your own way to do it. That's a good way to do it. But there's a reason why I stored muls separately. Is because let's say you want a pointer and then you can add attributes to that pointer. That's why I have mutable and immutable pointers, right? And that's why I want to add pointers, not non-null and null pointers. I need to have pointers as a literal separate type. Like they're their own thing. Buford says your approach also allows possible class hierarchy if you're into that. Really? You mean like object-oriented? Well, this isn't going for an object-oriented thingy. It's just simple plain old data, and I think I might add C++, like move and copy semantics, but that's about it. No object-oriented. All right, so parser.c. Let's get pfn in there. Parsing a whole function. What? Oh, that's the wrong one. Yeah, this is long. All right. Now I need to remove all of the stupid boilerplate to do with construction of the control flow graph. There's no control flow graphs anymore. All right. Well, we can do it like this. So, oops, that's probably desugaring. So we're not using the LIR at all. We should probably not. Yeah, just remove all this. Also the it's taking an LIR proc t as well. It's taking in a proc. No, it's taking nothing. But it is creating a just a proc t. Proc t. I know, but you can go back as if you're going to pointer types to obtain possible other types, aka force single inheritance. Yeah, yeah, that's. You'd probably need to be more fine-grained than just type equalities to do interning, but that's a good step. That's probably a pretty close step to what you're describing. Like it's pretty smart. Uh, yeah, you're right. All right, entry block with len args. So we're not creating blocks. Property sugar into match arms. So the entry expression is going to be a match expression. So how was that represented? HIR.h. All right, we're going back to the start. The let's go to the infix there. Okay. To do creates enum kind. Here, to do create enum kind. All right, where's the match? So it's just a single expression at the top, a list of patterns, and a list of expressions after. So let's just create it like this. We're creating a HI expert T expert, which is just that. All right, what we also need in the HIR is we need a way to dump expressions, duplicate them. So I'm gonna name like I mean allocate on the heap. I mean, so I think it'd be like this. Dump expert heap alloc. All right, just implement for me. Good. Easy. There's not much intermediate stuff I need to do. Also, I need to remind myself. Reminder. Reminder. Convert spaces. Tabs. Okay, just so I don't forget before I commit. All right, parser.c. Okay, so all this needs to be done is we'll run over this. Delete. Okay, so LIR local new, that we're getting rid of that. There is no LIR local new. There is only procs. Oh, this is the table. Okay, so we'll need to do this. We need to create a proc local new. And we'll take in a LIR. No, it'll take in a proc key pointer proc and a local. Oh wow, that was easy. That was super easy. All right. All right. Takes in a local t. It's a local immutable. None. A lock as well. Yeah. What I should do is lock none, because eventually I want to redo how locations work. Silly. All right. And then we're creating an LIR value, so we're not doing that anymore. We're gonna make a HIR expert T expert equals. And also, what I want to write here. Good. Okay. Kinds is a. These aren't going to be nodes, actually. I'm going to name these expert. What's this? Okay, expert underscore. Okay, good. All right, then we're constructing a local, so it's just this local v type. Actually, it'll construct it anyway. The location, none. All right, let's push them in here. All right, list of arguments. Construct a tuple. All right, that's easy. All right, let's construct the match expression in one go. So it's a kinds match type tuple. All right. Because we'll be appending to this. Okay. So p pattern is something different too. Yeah, we're gonna be after I do this function, I might end the stream. But it only requires some simple changes. So we create a new file called parser expert.c. Parser util, because I want to add the stuff. Oh yeah, we'll need the lexer and everything. So let's just take all of this. Talk debug stir next, ptalk to type, ptype prec, ptype expression, ptype, pimport, pscope register, ppush scope, ppop scope, pmask, palloc, pattern alloc, and ppattern. Pblock locate, and that's it. That's about all of the specific things that we need. All right, p pattern up. Put an name for it. No merging as that would break type equivalence. That should be really. Oh, this is a thing that did long ago. I need to fix. All right, now let's fix what takes in an LIR proc t. So that's wrong. That's taking a proc t. All right, and then we take a proc local new instead. Good. That's all that needed to be changed, except for this. Okay, p pattern needs to be changed in p.h. Takes in a proc. And then this also takes in a proc. Okay, so now we can pass patterns. All right, LIR block new. We don't need that. What we do need is, oh no, nothing. Okay, so just push scope. Great. HIR VOD takes an a proc. Block nothing. All right, no need for terminators. We've done just like that. Okay, we don't need this. We need a match dot patterns. Patterns. And then we need expers. Exper. HIR expertise. Huh. Again, P expert should return a non-pointer. That's what I wanted to do. That's how it's worked. Good. Great. I mean, we've essentially done this whole file. If we run it, we'll get a ton of linking errors, though. Delete the parent. We'll get an incredible amount of linker errors. So, I'll try and migrate as much as I can, but until then, I'm going to end the stream. So, while I'm migrating, ask your final questions, because I feel like I think that's it. Yeah, I've been neglecting my YouTube channel. After this stream's done, I'm gonna have 3 unreleased streams. So I'm gonna release those VODs. And then we had a couple nice conversations in the stream, and there's 2 streams before we had some nice conversations, so I might make those into nice clips. But I feel like this is a turning point for the language. Like, we dipped and we went back up, but we brought knowledge. Yeah, like, yeah. I feel like the language is going to be done in a week. All right, I said that was going to be done in a week 2 weeks ago, but now I mean it. Prometheus says, I want to try and make a C compiler for fun. But right now, I'm not sure where to start. Well, C is a simple language. There's like 20 keywords in it. You go to CPP reference C. All right, this is a great place to start. CPP reference. Please don't be Brian. Great. Okay, so take a look at CPP reference. So the C language is a simple one, right? But it's simple, but it's also not simple. It's built on simple concepts, but in reality, you'll be scrambling to fix millions of things. Because I mean, think of C for a second, and its legacy bloat. So there's 1, 2, 3, 4, 5, 6 different standards. They'll have all these things. There's GNU extensions. I mean, you want to support old code. You need to support full preprocessor. You need to support trigraphs. You need to support like all of these things. C, like, if you want to write a compiler, you should really not start with a C. If you've never written a compiler before. The thing of C is like, oh my god, like the function pointer syntax is crazy. I mean, it's like, I don't know. Okay, my best advice to you is this website right here. It's cppreference.com. It's a great website. It tells you everything you need to know about C. There's certain things about C you know already just from intuition, so you know how variables work and things like that. It's C in reality. If you cut out all the garbage, it's a simple language, right? You write a bunch of functions, interact with the world through extern functions. It's simple. It's simple as hell. I feel like you won't have much issue. It's just if you want to implement the whole thing, you're in for a lot. Yeah, I mean, I could have written a C compiler. I mean, you know, I might have. So if I was ever gonna interface to C, I'm not gonna write a whole C compiler. I'm going to write just enough of a C compiler to read headers only. That's what I'm gonna do. But for you, I mean, the best place to start is here. People have written C compilers all the time. A good reference is like, you can just look up online C compiler. I was gonna say tiny C compiler, but no, it's not for beginners. It is, it's not a mess, but you have a hard time understanding how it works. Yeah, I thought C is simple enough. I want to not. What other simple language is good for first compiler dev? Well, a good simple language for compiler dev is your own. Yeah, there's ways to simplify C where okay, C as a language is simple, but creating a compiler is hard. If you removed certain things, so let's say you remove 10% of C, it makes C 90% easier to implement. Okay, I'm simplifying. Let's say you remove half of C, it makes it 90% easier to implement. I mean, like the ramifications of that statement. I mean, that means that like there's certain things in C that are kind of unneeded and are legacy like craft. You know, the best language, the best language is like to write is your own language. Hi CI. Is that the CI from Discord? Thanks for following, by the way. I never thank followers, but right now I just saw that follow pop up, so thank you. All right. I think that's it. I think this is where I'm gonna clean up the stream. I think I'm gonna clean up the stream. So let's create a commit. So what I wrote here, remember to convert spaces to tabs. Okay, so with every new file in VS Code, it converts it to tab mode. Let's say, chat says, what are your thoughts on the direction they're going in Zig's development? Ditching LLVM. Oh yeah, so I read about that. Oh my god, when that came out, I read the whole thing. Or at least deprioritizing and making their own backend to make compilation faster, a la Golang's approach. Golang's main official compiler doesn't use LLVM as a backend. It's a blazing fast compiler. That's right. Now, what Go did is nothing short of amazing. Go created a compiler that is good enough to where it competes with LLVM and stuff like that. Now, that's the philosophy of a backend called QBE. What QBE does is implement 90% of the optimizations and 10% of the code. QBE and Go have a lot of things in common. I think I botched, 70% and 10% of the code. So Go and QBE have a lot of things in common. They have a simple compiler backend. I mean, I read the Go compiler backend. It is amazingly simple. It's just SSA, and then you run these certain parsers. So there's a lot of parsers, but it's just your bog standard SSA parsers. So you can create good enough compiler generation. Now what Zig is doing is getting rid of LLVM. So I read the whole thing. I know what they're kind of going to do. People are kind of mad because Zig marketed itself as like the C and C++ interoperability thing. You can get LTO and things like that. And then there's also people that are pissed off because they won't reach their performance benefits. But you can just brush all that aside. If they deprioritized LLVM, it'll be fine. So what they're trying to do is, my thoughts is yes, that is great. I had a talk. I talked to people in general. I talked to some guy about LLVM, and I talked about some specific things to do with how LLVM fucking sucks. It doesn't suck with its performance, but it sucks with its tooling. Well, it's not really tooling. It's just it's for one, it's a moving target. Two, it's huge. Three, since it's a moving target, the problem is further messed up by these package managers and things like that. Like, see, the thing is, Rust has issues with LLVM all the time. Zig has issues with LLVM all the time. I think that was a driving thing behind it. You know, V used to have an LLVM backend. I said before, I think a year before I got in the scene, V had an LLVM backend. For the same reasons, they ditched it in favor of C for good reasons, right? Because C is a stable, portable target. It doesn't move. And there's good things about C because it can be easily bootstrapped. I mean, the thing is with like LLVM is that imagine trying to bootstrap Zig. You need like the Zig bootstrap compiler, which compiles a trimmed down version of Zig, and you need like LLVM, and then you need a C++ compiler, and you need all of its stuff. I mean, it's like, for that reason, I'm never using LLVM. I'm never going to use it. What Zig is doing is great. What Zig is doing is great. What Zig can do is, I mean, I've read the Zig compilation pipeline. It's ZIR. Oh, it's like this typed thing, ZIR, and then you go down to, like, I think there's another step that I'm missing, but the last step is AIR. I think it's just called AIR. But they have this really nice like Zig analog, and they perform variable liveness analysis. They already have pretty good WebAssembly code generation. They have pretty good x86 code generation. I watched a video about a while ago about how Zig can incrementally compile, but also go into the already existing binary and like seek to a location in the file and like patch in like executable stuff. So if you change a constant in the file, it'll change it in like an operand of an x86 instruction. It can patch binaries. I mean, that's amazing. Zig already has the ability to do all of these things, right? I wouldn't say LLVM is holding them back, but it's annoying. It's annoying them. Like I hear stories all the time about how LLVM breaks in every update and they have to go fix it, and there's a reason. There's a reason Zig is ditching LLVM, right? I probably didn't give all the rationale, all the reasons. You want all the reasons, you can go read the GitHub article and things like that. I don't like LLVM. There's no way I'm ever gonna use it. So the compilation will be vastly faster. So it'll be vastly faster for Zig. They'll get faster compilation, and then they'll get faster code for that faster compilation. Essentially, what I mean is that they're doing more with less, right? If you don't do all the stuff that LLVM does, you can get fast enough code faster. That's essentially what I mean. Like LLVM came on the scene. I mean, you look at every new language nowadays, you check inside, what is it? Like, oh, this is a new language. And it just uses LLVM. Like, it's like, there's barely any innovation anywhere. I mean, what Zig is doing is great. And I need to see more of it. And people are doing it, which is great. So, sorry, I talked for a while, and I've reiterated a couple times. It's just a way to talk. All right, so let me just convert all of this to tabs and spaces. Indent using tabs. Indent using tabs. Chat says, do they lose portability though? Okay. Now the portability issue can be solved through multiple reasons. Can be solved through multiple ways. Portability. I mean, there's only like 3 main instruction set ISAs out right now. There's ARM, x86, 64, and RISC. ARM, RISC, and x86. All right, they're the three main ones that are out there right now. All right, so you only need to create 3 different backends. So that's really all you need to do for 3 different backends. The thing is with portability is, there's not really many different things. Now, though, what if you wanted to compile for a MIPS machine or a 8086? Not 8086, but a MIPS machine would be more like applicable. In that situation, I mean, the Go compiler has MIPS, which is great. The Go compiler has MIPS and Spark, but in that situation, if I were in their shoes, I just generate C. And what they do is they generate WebAssembly as well. The thing is, GCC is better than LLVM in the sense that GCC supports more targets than LLVM does. So in reality, I mean, they still lose certain amounts of portability by using LLVM. It's more like the portability issue can be solved by just not. It's not really that big of an issue. If you want to support literally everything in the whole world, output C. That's what I'm going to do. I'm going to output C. I'm going to output C as a secondary thing, and then I'm going to have WASM and some other couple of instruction set ISAs But if I want people to like bootstrap my code, I generate C, and it's super simple. CII says, if we generate C, why would we need to implement optimizations at all? Well, there's a reason why Rust has an MIR, mid-level IR. It's for language-specific optimizations that C has no idea about. Let's say you construct like there's certain optimizations that C can't understand. So specific things like data flow optimizations, mutability. The C aliasing model is pretty bad. The C memory model kind of sucks. Like to do with aliasing and restrict pointers and things like that. C will never get them all. There's a reason why I'm creating an LIR and then running optimizations on that LIR, and then I'm going to create another IR. This is it's this thing. It's like C is great. It's pretty portable. It's like the most portable instruction set. Like no, it's not right, but it's the most portable thing in the world. But it can't get everything right. That's why I'm having my own intermediate representation thing. This is what you explained is what V does. V does barely any optimizations. It just generates a big blob of C. So you can go that path. Yeah, there are certain assumptions that each language have, but those assumptions do not exist in the C runtime. That's right. You can do certain things a certain way, and yeah. So that's what Rust has an MIR. Zig has a ZIR or AIR. That's right. Okay, so let's go one by one and did using tabs. See, look at that. Okay, that's did using tabs. Okay, I want no spaces. It's fine. No spaces. I don't want any spaces. Okay, good. Some tabs. Oh, yeah, this is in spaces. Oh, I hate spaces. Wow, this isn't even in tabs. Okay. All right. After this commit, I think that's it. That's it. That's it. It's a lot of files. So many. All right. What am I gonna name this? I'm gonna name this the. What's the last commits that I did? Buford says, one example I can give is the double-double equality in JVM languages. One is class and the other is a plain value. I heard about this. Well, I didn't hear about it. I read about it. It's this thing that's been out for a while. Yeah, I have some kind of knowledge on this. It's like there's like a reference equality and value equality. Well, I think that's something that can translate pretty easily to see. Yeah. All right. So what stream is this? This is stream 13. Wow. So this is a parser LIR plus HIR. And I'm going to name this like revive HIR. I yield. Revive HIR. No, I give up. Okay, I'm not going medieval. I give up. Good. I give up. Enter. And then let's sync it. All right, I think that's it. So I'm gonna end stream. If anyone else has anything to say, say it now. But and I think that's it. I think that's it. I think that's it. Thanks you guys for showing up and just asking questions. Like I really enjoy this. I really enjoy asking questions, answering questions. Go and get them. Yeah, it's funny. I have like 131 followers. All right. That's it. Thanks, guys. Thanks for showing up. I'm done now. Bye. Good stream.